Hey guys, and welcome to another episode of Damo is in the class. Today, we just want to hop right in, but I'm so happy you took the time to stop by. So, today's aim is using strategies and properties to divide one digit numbers. All right, so problem number one. Mrs. Jones is setting up tables for a party. She can seat 8 people at each table. There will be 115 adults and 35 children at the party. How many tables will Miss Jones need? All right, so we have choice A, that's 18, choice B, that's 19, choice C, that's 142, and choice D, that's 150. So the first thing we need to do, we need to understand what is it that we need to do to solve this problem. Well, let's first see, the first thing we notice is that it's actually a two-step problem. There's more than one thing we have to do, so that's why we call it a two-step. Our first step would be we need to find out the total number of guests that's going to be at the party. We already can see we have 115 adults and 35 children. We need to know our total first before we can do anything else. So let's start with that. All right, so we're going to write 115 plus 35 so we can do that math and figure out how many students and people, we have in total.
5 plus 5 equals 10. The 0 and the 1 will travel to 1. 1 plus 3 equals 4. Add one more, 5. 1 plus 0 equals 1. 150 people in total.
Good job. All right, so like Jamir told us, we have 150 people in total that's going to be at the party. So now that we know we have 150 people, we can start our second step. All right, so our second step is going to be we need to see out of the 150 people, how many tables will she need if she seat 8 people at a table? So therefore, we're going to have to divide 150 by 8. All right, so like I said, 150 people, we're going to divide that by 8. So what does that look like?
150 in the house and 8 in the side.
All right, good job.
8 is on the side. So 1 is too small. So now I'm going to say on my 8 groups, it's going to get to 15. 8 times 2 equals 16. So we went past 15. So you only take us one group. 1 times 8. 1 times 8 equals 8. Subtraction didn't equal. 15 take away 8. 9, 10, 11, 12, 13, 14, 15, 7. So now we just have to put on the number. 70. So now we say I'm 8 groups, it takes to get to 70. 8 times 5 equals 5, 10, 15, 20, 25, 30, 35, 40. 8 times 6 equals 41, 42, 43, 44, 45, 46, 47, 48. 8 times 7 equals 49, 50, 51, 52, 53, 54, 55, 56. 8 times 8 equals 57, 58, 59, 60, 61, 62, 63, 64, 64, 8 times 9 equals 65, 66, 67, 68, 69, 70, 71, 72, 72, but we went past 70, so now we have to use 8 times 8. So we have to put the 8. 8 times 8, 64. Fraction gonna equal, count them until we get to 70. 65, 66, 67, 68, 69, 76.
All right, so as we see Jamir, he did an awesome job and he got 18. So as you see, we do have a remainder of 6. So these is not just 6. This is 6 people, remember? So because we are trying to sit them 8 people at a table, this just tells us that there's 6 people left over. And because they're people, we need an extra table. So the answer would not be 18. It's going to be choice B. It's going to be 19. Why? Because we have 6 people left over that we still need to seat at the party. So these could be a little tricky when you see that, but when it's dealing with people or boxes, containers, or anything that you need to put stuff in, if there are any left over, you're going to need an extra one to fill that up. So you're just going to add 1, and that's what's going to give you the 19. All right, so as you see, we did solve the first problem. But before moving on, Jamir still has a little problems forgetting and remembering some of the steps with long division. And he might not be by himself. So I decided to go back and go over the rules again. Once again, this is all a review. So I wrote down the rules, and you can always write them down as well. Number 1, look at the first number under the house to see if it's less than the number on the outside of the house. For example, we have 125 inside the house, we have 5 on the outside. So at that point, we will look at the number 1 to see if 5 is greater than the number on the inside. And for this instance, 5 is greater, so therefore we cannot use the first number. As we see in our second step, it tells us if the inside number is smaller, then look at both first and second number to then find groups of the outside number of the house. For example, now we're going to look at 5 going into 12 instead of 5 going into 1. And with that being the case, we would have to then decide how many 5 groups can we get to get as close to 12 as possible. Once we find our number of groups needed, we put that answer on top of the second number under the house. Example, we have our 5 divided by 125, and we put that 2 right over top of the 2, which is inside the house. Then we do the multiplication of the number on top of the house with the number on the outside of the house. Example, we have our 2 up on top, we have our 5 on the side, and we're doing our multiplication. 5 times 2. That's how we get our 10. All right, so now we set up for subtraction and solve. Example, 5 times 2 gave us a 10. We take our minus sign and we draw our equal. We do the subtraction. 12 take away 10 leaves us with 2. Then we bring down our next number under the house and then find the number of groups needed to reach our new number. Example, we did our 5 times 2. We got our 10. We subtracted 12 take away 10. We got 2. And we brought down our 5, which gave us a new number of 25. So now we need to see how many groups does it take to get us close or to 25. After we find the number of groups needed, we put the answer on top of the house, on top of the third number. For example, we have our 5 groups that we know that it takes us to get to 25, and we put that number right over top of the 5 that's inside the group. And then we repeat step number 4. which is multiplying our top number by our number on the outside of the house. Then step 5, we set up our subtraction and solve. Our example, 5 times 5 gave us a 25. We took our minus sign and our equal sign. 25 take away 25 leaves us with 0. So now we know 125 divided by 5 is 25. All right, so hopefully guys, going over the division will help you with these next set of problems. So now, which problem below results in the answer 8? Camille had 44 baskets. She placed 8 books in each basket. How many books did she place in each basket? Choice number 2. Camille had 47 markers. 6 markers are in each box. How many full boxes of markers did Camille have? Choice number 3. Camille had 45 pencils. 6 pencils fit into each of her pencil pouches. What is the fewest number of pouches she needs to hold all her pencils? And our last choice, Camille had 50 crayons. She placed 9 crayons in each bag. How many bags did Camille need to hold all her crayons? So guys, we're going to take each one by one to see which one results in our answer of 8. All right, Jamia, so I'm going to repeat the problem. Camille had 44 baskets. She placed 8 books in each basket. How many books did she place in baskets? So you're going to, exactly, good job. That's right, we're going to put 44 in the house and 8 on the outside. Now what we're going to do, Jamia?
First one though is 8 bigger than 4. Yes, so now we just have to see how many 8 groups is it going to take to get to 44.
All right.
I'm going to start at 8 times 5 to see what is you get us closer to 44. 8 times 5 equals 5, 10, 15, 20, 25, 30, 35, 40. 8 times 6 equals 41, 42, 43, 44, 45, 46, 47, 48. We went past 44, so now we just have to use 8 times 5. So now I'm going to put the 5 on top of the 4. 8 times 5 equals 40.
Good job. We're at 40, so now I'm going to count up to 44. 41, 42, 43, 44. 4. I got 4 left over, so we have to write remainder 4. Or 4. All right, so we do have a remainder of 4, but like we said, anytime we're boxing things, putting them in albums, or organizing into any type of containers and putting them into any type of groups. The thing is, when we have leftovers, which are called remainders, we still need to put them in a group. We can't just leave them normal and just say it's just left over. Those 4, which is the remainder, those need to also be inside of the basket. So instead of having 5 baskets, Camille would need 6 baskets if she put 8 books in each, because she still needs a basket for those 4 books. So the answer isn't 5, it's 6. But this choice 1 is still incorrect because we need an answer of 8. All right, so now choice number 1 was incorrect. So now we're going to go to choice number 2. Camille had 47 markers. 6 markers are in each box. How many full boxes of markers did Camille have? So, Jamia, what are we doing?
47 in the house and 6 on the side.
All right.
First one was 6 bigger than 4. Yes, no. So now we have to see how many 6 groups it will take us to get to 47. We'll start at 6 times 5. 6 times 5 equals 5, 10, 15, 20, 25, 30. 6 times 6 equals 36. 6 times 7 equals 37, 38, 39, 40, 41, 42. 42. 6 times 8 equals 43, 44, 45, 46, 47, 48. 48. So we went past it. So now we just have to use 6 times 7.
Good job.
So now I'm going to put a 7 on top of the 7. 6 times 7 equals 48.
Try that again. 6 times 7 equals what?
42. Fraction didn't equal. Gamma took it to 47. 43, 44, 45, 46, 47. 5. R 5. She needs 8 pouches, so this one is also the answer.
Alright guys, so like Jamir said, we have also a correct answer. So far we have 2 of these statements are correct. So let's check this last one. Camille had 50 crayons. She placed 9 crayons in each bag. How many bags did Camille need to hold all her crayons? So what's going to be our problem now, Jamir?
50 in the house and 9 on the side.
Good job.
The first one you see is 9, and we're making a 5. Yes, and now we have to see how many 5 groups is going to take us to 50. We can start at 9 times 5. 9 times 5 equals 5, 10, 15, 20, 25, 30, 35, 40, 45. 45, 9 times 6 equals 46, 47, 48, 49, 50, 51, 52, 53, 54, 54. But we went past 50, so now we have to use 9 times 5, 45. So now we have to put the 5 on top of the 0. 9 times 5 equals 45. Come to get to 50. 46, 47, 48, 49, 50. 5. R 5. I have an R remainder 5. So we need one more bag. So we need 6 bags of crayons.
Good job.
We got 6 bags and needed 8. So this one is wrong.
Good job. Alright guys, so here's our last problem. 2 children wrote 5 number cubes and recorded the number created. A's number is 53,214 and L's number is 32,145. Choice A. The 1 in L's number is 100 times more than the 1 in A's number. Choice B. The 4 in A's number is 10 times more than the 4 in L's number. Choice C. The 2 in L's number is 10 times more than the 2 in A's number. And lastly, choice D. The 5 in A's number is 100 times more than the 5 in L's number. So as normal, we're going to start working this problem one choice at a time. Alright guys, so the first thing we want to do is write both numbers. We want to write our number for A and our number for L, but we always want to include our labels over our numbers, which will be our place values. Our ones, our tens, our hundreds, our thousands, and our 10,000s. We want to make sure we identify those places so we can be able to answer these problems. Alright, so choice A. The 1 in L's number is 100 times more than the 1 in A's number. So let's look. Here you have your ones underlined. And tell me, where is your ones at in L's number? And what place?
The hundreds.
And in A's number, where's that one?
In tens.
So is that 100 times greater? Is L 100 times greater than A?
No.
What is it?
It's 10 times greater.
Exactly. So that means choice A is wrong. All right, so choice A is incorrect. Jamia is right. So we're going to move on to choice B. And the 4 in A's number is 10 times more than the 4 in L's number. So, where is the 4 and what place value is the 4 in L's number, Jamia?
The tens.
Exactly. And in A's number, where is the 4?
In the ones.
So, is A's number 10 times more?
Yes.
Look at that again. Where's A's number?
In the ones.
Okay, he's in the ones. And where's L's?
In tens.
But they saying A's number is 10 times more than L's number. Is that true?
No.
Exactly. It's the opposite. L's number, right, is 10 times more. So choice B is also incorrect. All right, so now let's move on to choice C. The 2 in L's number is 10 times more than the 2 in A's number. So we're going to go ahead and underline the 2 in both numbers. All right, Jamia? So, where is the 2 in L's number?
In the thousands.
And where is the 2 in A's number?
The hundreds.
So, is L's number 10 times more than A's number?
Yes.
Good job. So, what does that mean?
Choice C is correct.
Great job. Choice C is definitely correct. All right, guys. So, like you know, we're still going to work our last choice. So, last choice D. The 5 in A's number is 1,000 times more than the 5 in L's number. So, let's underline the 5 in A's number. And where is the 5 in A's number, Jamia?
In the 10,000s.
Exactly. And where is the 5 in L's number?
In the ones. The 5 are in the ones in L's number.
And where's the 5 in A's number?
In the thousands. In the 10,000s.
Exactly. And how many places is that away? If you count the places, how many places from the ones to the 10,000s, how many jumps would you make? You're starting at the tens as your first jump. So you would jump from the ones, you would go 1, 2, 3, 4 places. So that would give you 10,000 and not 1,000. So this one would be wrong. If it was only 3 places away, it would be thousands. But in this case, it's 4 away, so it's 10,000s, so this one is wrong. So choice D is definitely wrong. All right, guys, so Jamia was correct. D is definitely incorrect, and our only correct answer is C. But I do want to explain, how do we decide 10 times, 100 times, or even 1,000 times, or 10 times 1,000 greater? So each time we move one place, that would be 10 times. So this place from the ones to the tens would be 10 times greater. If we go 2 places, that would be 100 times greater. We go 3 places, that's 1,000, and 4 places is 10,000. So for our last problem, as we said, the 5 was in the ones, and to get to the 10,000s would be 10, 100, 1,000, and 10,000. And that's how you decide how far 10 times, 100 times, 1,000, and so on. And I also wanted to add one last thing. When you're doing these things and you feel like you're confused, all you have to do is simply make sure you always include your labels. Your ones, your tens, your hundreds, your thousands, and your 10,000s. This way, you can always be certain on which place that you're looking at. That's just a tip for me. All right, guys. All right, guys. So I hope you found this video to be useful and found some tips and tricks. Until the next time, it's not about what you don't know, but what you're willing to learn.